because that is going to be, yeah, I think we can just write like this: half multiply by square root 80. And that's going to give you an answer of 2, 5. And yeah, the reason was line from center perpendicular to the core. That was our reasoning. Everyone understand how I got this? Okay, good. Now, moving on. Question 9. 2 more questions to go. Is it also Euclidean geometry? In triangle ABC below, M is a midpoint on AB. Yes. And N is a point on AC, which is that over there, such that MN is parallel to BC. Prove that, prove the theorem which states that, okay, then all of that is written there. So this is a bit weird again. So that is actually going to be, see here, AM over MB. We must prove that AM over MB is equal to AN over NC. Now, whenever you need to prove things like this, the first thing you need to do is draw, you need to draw lines across, right? You need to draw perpendicular lines for this to work. So we're going to make a perpendicular line like this. We're going to make it across like that. All right, let's just call that one line H. Eventually, you're going to have to make a perpendicular line across like this, just to make it easy to work with. This one is going to be line L, right? That is a cursive L that we have. So now we have different types of triangles. We have a triangle AMN, because remember we want to be speaking about these different parts. So we need parts that has this M and N in it, and then we need a part that has the B and C in it. M is going to be in both of it. So what I'm going to do is, I'm now going to show you we have, yeah, this is one of the ones that we have. So in order to calculate it, we're going to say the area, we want to prove this, area of triangle AMN, which is the AMN, which is this entire big one over here, is going to be divided by our area of our MBC. So it's the bottom part over here, right? MBC. Remember, we're going to put perpendicular lines, so we'll go so, boom, and the side as well, boom. That's just supposed to meet up over there. That's right. Okay, so we're gonna have it like this, right? So okay, now we have it like area AMN divided by area divided by MBC. So in that particular case, we're going to say, because it's the area, it's going to be half of our base, which is AM, times the height, or not the height, sorry, times H, because the vertical part we have over here. All that is divided by our half. This is MB now. That's the base. MB, which is the base in this one. It will eventually lead up to here as its base. Because it's dealing with that triangle, MBC. We're going to also have it as a H. So we're going to say that. Then what's going to happen here? They will cancel, and that will cancel. So therefore, that area is going to be equal to AM over MB. So that is this. AM over MB. Okay, so yes. Now I'm going to bring this over again. Now we're going to look at the next area. So again, but this time I'm going to deal with triangle AMN, the whole big one over here. But this one is going to be now compared to NB and the C on the side. So earlier we've done it the other way. Now we're going to be dealing with these three. So we again take the top triangle and we're going to show it at the bottom. So the first one I was dealing with the MBC. So we are now going to say this is going to be our area of triangle AMN Because remember, we're dealing with these two. Want to make sure they equate to each other. Area of NBC is equal to, in this particular case, it's going to again be the half of the base. In this case, it is A and N, and in the other one is going to be N and C, because you're breaking it apart like this now. So this is going to be half AN times the different one now, not the H. I'm going to do the other side, so it's the L all over the half of NC, because we want to show that these links up with each other. Now, do we have things that's the same? Yes. Cancel, 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 cancel. So that's equal to AN over NC. So therefore, you can actually say that AM over MB, which was the first one we done over here, AM over MB, which is the spot, boom, is equal to our AN over NC. And that is how you get to answer. And that's also we show that we get this. Remember, that was what the answer was here, to prove that it was stated. Took it away a bit earlier, but yeah, if you go back, you'll see that's what we had to prove. So this is proof that these are the same. Okay, now moving on. 9.2. In the diagram below, triangle PQR is drawn. EG is parallel with QF, and EF is a straight line. QE ratio is ER. Yes. So the QE to ER ratio is equal to 2 to the ratio of 5. And then PR is equal to 49 units. The last thing they tell us is FG is equal to 10 units. For 9.2.1, we to calculate the length of GR with reasons. It's going to be worth 4 marks. So, okay, what do we know here? QE. QE is 2. QE equals 2. ER equal 5. ER equal 5. But that's the ratios, right? PR 49. Good, good, good so far. FG equals 10 units. What do they want to know? GR with reasons. So we need to know what GR is. GR, we don't know, but we want to try and find out. This is going to be worth 4 marks. Now, let's see. We have GR over here. Seeing that they're dealing with the ratios, we're going to try and deal with the ratios as well. So we'll take our GR and we're going to deal with this section over here, right? That's going to be, they are speaking of the E, the QE, and the QE and EG, right? The QE and ER. So do you see here, here's the ratios of QE, which is this, to the ratio of ER, which is this. That's 2:5 units. So what I'm going to do is I'm going to take these two parts as well, but now I'm going to compare it to GR, which they want, which is GR this over here. So this GR, and compare it with the one directly next to it as well. We're not going all the way to FG. So we're going to write it like this now. I said, let's erase that. So that is now going to be GR, which is this part that I want now, GR, over FG is equal to, like the ratio they had, which is ER. So just like they had, ER over QE. Right? We have it like this. Now I plug in the values that we know. So GR is equal to FG. FG is 10. So we'll plug in 10. And that is equal to ER. 5 over QE. QE 2. We have 3 things and we just need to know what GR is. So now we're going to make this the subvalue formula. So we are going to say 5 divided by 2 and then multiply that by 10. So therefore, GR is going to be equal to 25. And that is going to be our 9.2.1 with 4 marks. So we just took the parts that was given to us, parts of the sections that we had here. We broke it up. These was the ratio, so we used these two. This was an unknown, and this was a known as well. So we just made it equate to each other, and then we went further. Now, 9.2.2. Prove that FE is parallel to PQ. So, okay, FE needs to be parallel to PQ. This is going to be worth 3 marks. Now, we initially know that, okay, when we deal with this, this is parallel, right? So it's not perpendicular, so we don't do the gradients, which is -1. We're going to change this up a bit. In this particular case, we need to make sure that they are equal to each other. If FE is equal to PQ, then that's going to be the same, right? Then they're actually perpendicular with each other. So we're going to do it like this. We know things now about FG, which is going to be 10. We know GR, which is calculated as 25, right? So that means if we take just from F to R, let's just write that down. FR is actually going to be equal to FG plus our GR. And that is 10 plus 25 that we have over there is equal to 35. So that is going to be our FG. Now that we have our FG, we are now going to change this up, and we're going to now once again put these denominators, right? We put them over each other, right? Using proportionality. So in this particular case, we're going to go, and now we're going to look, okay, what is left? We dealt with this, but we didn't deal with this part here, PF. PF is the one we're going to need to try and find out. So it's going to be PF. Is the part that we want to know. What do we know now? Well, we know the entire FR, which is calculated, so it's FR. Well, what else do we know over here? Well, we're just going to equate these to each other just to make sure how much we have. So a PF, all right, that is going to be from this side that we have this part over here, PF, and that's going to be 2. All right, so we're going to have this 2, and then we're going to bring that section over. PF is going to be this. So actually must calculate PF, yes. So PF, thought, yeah, we're going to try and get that in there, is equal to our PR that we have in total, which is 49, minus our GR, which is 25, minus our 10. And that will all give us just what PF is. There we go. So that is going to be 49 minus 25 minus 10. 49 minus 25 minus 10 is going to give you 14. Now we know what that is. So 14 is PF. Now we can say 14 divided by 35, and that's going to give you a value of 2/5. That is what PF over FR is. All right, so that's going to be our PF over FR. It's going to be this whole section here. This to here. Now, we are going to now check how PF is in terms of this part. Right, this whole section over here. This whole section here, right? So we have this whole section here. So now we are going to say, based on how it is looking, these two parallel with each other, and we want them to line up. So if we say our PF over our FR going to be equal to our QE over ER. That will also be equal to 2/5. So that's going to be this section over here, QE. Remember, this QE is what we get here, 2. And then this FR is going to be, sorry, not FR, ER. Sorry, but to make it the ER is what's up. ER. Yeah. QE over ER. So this values here was PF over FR was equal to 2.5. But this section here, where you say QE over ER, which is this, QE over ER is also 2.5. Remember, it's a ratio, so 2 over 5. So both of them are the same. Therefore, we say they are parallel to each other. Another way you could say it is that FE is parallel to PQ, why? Let's get this way in working again. Come on. Actually, the converse of the line that is parallel to your third line in the triangle. There we go. So okay, and that was 9.2.2. Okay, now moving on to the last question. All right, I know you just see that over there. That is just because I show, okay, that's going to be where the question is going to be left over. Right, so we're going to have that. Now, question 10. Here we go. 10.1. Well, that actually supposed to say it is that's supposed to be CT over PC is equal to 1 over 6. And we must prove that CT over PC is equal to 1 over 6. So CT is this part over here, CT, and we must prove it that it is CT over PC, which is this PC over here, the big line. Right, so just part of it for this one needs to be equal to 1 over 6. So in this particular case, we were told that in the diagram below, A, B, C, and D are joints on the circumference of the circles. Okay, we know that's that. PC and QC are drawn from P and Q respectively, yeah, and intersect at C. QP is joined. DB is parallel to PQ. So DB, yes, is parallel to PQ, yeah, and they gave the arrows to mark that as well to show that. QB is 5BC. So QB is 5 of it, right? So 5. That's what I have here. Okay. Okay, so we have it just like this. So okay, in this case, so here they say this is the CT over PC is equal to 1 over 6. Well, okay, let's show that. So the way we can write this is, so remember this is what we're trying to get now. CT over this. I'm going to write that on the side. CT over PC is equal to 1 over 6. That's what I must try and get. That's what I must try and prove. So, okay. Let's see. So CT over PC. So we write it down, CT over PC. So we can deal with the other side of the triangle, so on the opposite side. So only this section first, just like we took the first part, deal with BC over the entire one. What is it a part of? QC. So we will just say it says BC over QC. So we take a part of it, divided the entire section. So in that case, we have it just like this. So BC. All right, yeah, they said it is part of the circle. Right, and that's going to be 5. And then this is just a part of it. So that's actually going to have to be just x zone. All right, so that's going to be just x on its own. So that's x, and this is going to be our QB, which is this QB plus this x over here. So our QB plus our BC. So that is actually going to be equal to our QB is 5x, so it's x over 5x plus only x. So therefore, that's going to be CT is equal to PC, and that's equal to x over 5x plus x is equal to 6x. X is cancelled, so that's going to be equal to 1 over x, 1 over 6. And that's how we get this one, so 1 over 6. Okay, then. Okay, now we have that done. Now we move on to the next one. 10.2. Triangle QAC similar to triangle QBD. This is going to be the last question of the exam. So when it comes to this particular section and you see the similarities, all you're going to have to do is the proportionality theorem. So which parts do we know? Well, we're going to link all of this together and we see which ones we can use. We have QA over QB is going to be equal to our QC over QD, proportionality theorem. So we have it with our AC over BD as well. They have values for our QA with our QB and D. So we need to see what has all of it. Well, it's going to be these two. So we're going to focus on this one and this one because it has values in each. So we're going to bring it over like that. Okay, so when it comes to QA, multiplied by our QD now, that is going to be equal to our QB, which we're going to bring it over, multiplied by our QC. So we said QB is 5 of BC, right? And the reason why we know that now this is 5 BC, 5 of BC is, so this is just x over here. That's where we got it from, just showing you quickly. This x here. We were told that this is 5x, so this is 5. And this on its own, it's just x, because it's 5 times our BC, which is this over here. So that's where we got that. So that's 5, and then that's this sixth one that we had. So QB was just 5, and then BC was just 1. So moving on to this one, a QB is equal to, let's get a bit more space. So that is now going to be equal to, so our QB is actually going to be 5, they said, is going to be BC, 5 of BC, multiplied by our QC, and that's going to be our 6 of our BC. Where do we get that? In our answer we just got right now, right? In 10.1. That's a 1 over 6. All right, so we get this over 1 over 6. So we get that over here. That's 1 over 6. And then now we're going to multiply these together. So we're going to say our, let's move on to the next slide. We have our QB over BC is equal to, how much is it? 5 over, that is only 1 of it, right? It's only worth 1. That's where we get our 5. So we then say it's going to be our QA times our QD is equal to, how much will this be now together? Well, it's going to be, as we brought over, we inverted. So this is BC. Those are going to be multiplied by each other. And this is going to be multiplied by each other. So we flipped it around. So that's going to be 5 multiplied by 6. 5 multiplied by 6 is going to be 30. So that's going to be 30 BC squared, which was 2 BCs. And that's what QAD is. QA times QD is equal to 30 BC squared. And that is going to be with 3 marks. Yeah. And that's how we're going to get that answer. Okay, so yes, I hope everyone understands it a bit better now. Sorry that we went so long over time. I tried to go a bit fast and things, but it just looked like I didn't finish a bit earlier. But thank you all for joining this lesson. Thank you for taking time out of your Saturday in order to enjoying this lesson. All the best with paper 2 that is coming up now on Monday. Please feel free to send reviews on everything. And all the best. Watch this in relation with your other paper as well. Other than that, on behalf of myself and co-hosts and things, please enjoy the rest of your weekend and all the best with the exams. Thank you.